Hello everyone, welcome to this video series on cryptography and network security lab. So today we are going to look at the theory associated with program 8. So before going into the program, like and share this video and also subscribe to my YouTube channel for notifications on latest videos. So this program 8 is about implementing encryption and decryption using Randall algorithm, also called as AES algorithm. Okay, so the abbreviation of AES is Advanced Encryption Standard. Okay, Advanced Encryption Standard. And like DES and block cipher, AES is also a symmetric block cipher. And AES is very popular. No weakness has been found in AES until now. Also, AES is used in many protocols in the real world, in the internet and other applications. Now, let's look at some parameters or characteristics of AES. Actually, there are three, what should I say? You can think of versions of AES: AES 128, AES 192, and AES 256. So, if you look here, what is this 128, 192, and 256 means? It's the key size. Okay, and also associated with the key size, correspondingly, there is one more thing called the number of rounds. Okay, so the actual key size is based on the number of rounds. For example, if you are using 10 rounds in AES, the key size is 128 bits. If it is 12 rounds, the key size is 192 bits. If it is 14 rounds, the key size is 256 bits. Okay, the remaining things, plain text size, ciphertext size, and round key size, all are same, which is 128 bits. Only the number of rounds and key size are changing, so keep that in mind. Now let's look at the overview of AES structure, particularly encryption, what is happening in the AES encryption. So the plain text size is, as you have seen in the previous slide, 128 bits. Also, if you convert 128 bits into bytes, it is 16 bytes. The given plain text or the plain text block is converted into input state, is represented as input state. Okay, so this is 4 by 4, which is 16 bytes. So each square is a 1 byte. Not exactly 1 byte, 4 bytes. So in total, 4 by 4, 16 bytes. So each square is 1 byte. Okay, so 4 by 4, 16 bytes. Right, now this input state goes as input to initial transformation step. Okay, so some changes are going to be made to the input state, and the output will again be 16 bytes. So this is the output of initial transformation step, and the output goes as input to round 1, where in each round there are 4 transformation steps being applied. We will see what are those 4 transformation steps. Okay, so as I told you in the previous slide, the number of rounds can be 10, 12, or 14, right? So in general, if you think of, there are n number of rounds from round 1 to round n minus 1. So in every round, there are 4 transformations which are being done on the input state. Okay. Now, why I have written it as n minus 1 means because in the nth round, there are only 3 transformations being applied. One transformation is removed. Okay. So in the final round, only 3 transformations are being done. And the output of this last round is called the final state, which is the ciphertext that is sent to the receiver. Okay, so the process is not completed. So each step here, that is initial transformation, round 1, 2, 3, so on up to n, each round takes as input a round key. Okay, so the round key is generated by the key expansion algorithm. So how many keys are there? Total 0 to n, that is n plus 1 keys are being generated. All these keys are generated based on the input key, which is m bytes. So what is the size of key here? What is this m? So if it is 10 rounds, the size is 128. Okay, 12, if it is 12 rounds, 192, and if it is 14 rounds, size is 256 bits. Okay, so this is the overview of AES encryption. Now, what are the four transformations that I was talking about? Are these are the four operations. First one is substitute bytes, second one is shift rows, third one is mix columns, and fourth one is add round key. Right, now let's look at in more detailed way what is happening in the encryption. uh, so if you see in the previous step, there is this initial transformation, right? So what is this initial transformation? Is simply uh, XORing the input state with the round key. Okay, simply XORing the input state with round key. That means this and this. That is the initial transformation. Okay, now the output of this initial transformation is going as input to round 1. So as I told you, every round has 4 transformations. Not every round, n minus 1 rounds has 4 transformations. So this is the order of transformation: shift, substitute bytes, shift rows, mix columns, and add round key. So this happens up to n minus 1 rounds. If you see in this figure, we are taking 10 rounds. Okay, so from 1 to 9 rounds, there are 4 transformations in each round that are being applied. And in the last round, 10th round, one of the transformations is removed. So which transformation is removed? The mixed columns transformations is removed. Okay, and the final output of round 10 is the ciphertext. The final output of round 10 is the ciphertext, which is sent to the receiver. So as shown in the previous diagram, every round and this initial transformation will get a round key, right, which is generated by the key expansion algorithm. So these are the round keys. Okay, so here W of 03 means W0, W1, W2, W3. So each W0, W1, W2, W3 are of size 4. Okay, I mean 4 bytes, right? So this is actually 16 bytes, and ciphertext is also actually 16 bytes. So I made a mistake. So this is not bits, this is bytes. Okay, and the decryption process is like this: the ciphertext goes as input to the decryption algorithm, and the first operation is the initial operation, which is the add round key, like this. And if you see here again, in decryption, the round 1 operations are like this. So if you see here, it is different from this round 1, right? So the encryption algorithm and decryption algorithm are not same in AES. Remember that. Okay, so first shift rows, inverse shift rows is performed, inverse substitute bytes is performed, add round key is performed, and inverse mix columns is performed. So this sequence of operations or transformations goes on up to round 9, n minus 1 rounds. And in the final round, again, one transformation is removed. What is that? Inverse mix columns is removed. And the final output is the plain text. So this is the decryption process, and the input keys you can see here. So the input to the initial transformation in decryption is this one. So for round 1, the key is this one, so on up to last round. Okay, I hope it is clear now. Now let's discuss in detail about these 4 transformations that are happening. Right, so the 4 transformations are substitute bytes, shift rows, mix columns, and add round key. Now let's look at the first operation, which is substitute bytes. So the input is a 4 by 4 matrix, I mean 2 by 2 matrix, which contains 16 entries, right? So actually what we are using in substitute bytes uh, transformation is we are using an Xbox, which is a 16 by 16 Xbox, and a particular entry in the input state goes as x coordinate and y coordinate into this S box. So it's a simple lookup operation which is performed, and the entry at the intersection will be given as output. So this is the new state. So this is the input state and this is the output state. Okay. So for each uh, entry in this matrix input state, a lookup is performed into S box, and the corresponding value in the S box will be replaced into the output state. That's all. So this is substitute bytes. And shift rows, it goes on like this. So the first row in the input state and the output state is same, no changes are done. Okay, if you see here S00, 01, 02, 03, and here also S00, 01, 02, 03, right? Now for the second row, we are doing circular left shift by 1. For the second row, we are doing circular left shift by 1, like this. So you can see this S11 is moving into first position, S12 is moving into second positions, and so on. And the second and the third row is circular left shift by 2 positions. Okay, so you can see S22, which is the third entry, is moving to first. So because it is left shifting by 2 positions. And for the final row, it is circular right shift by 1 position. Okay, so this is how shift rows transformation works. This is also very simple. And next one is mixed columns. So here is the input state, and what happens in mixed columns is actually this is a predefined matrix which is already specified by AES developers. It is a predefined matrix. Okay, now you take one by one column into here and you multiply this and you will get a result. That result is placed like this. Okay, so you take the second column, you place it here, you perform the matrix multiplication, you will get the result and put that result into second column in the result state. That's all. You will do this for each column. So this is mixed columns. And last transformation is add round key. You take the input state and you XOR with the round key. So if you see here, not here, if you see in the previous slides, uh, the keys are generated like this, right? 4 set of keys are being generated. W0, W1, W2, W3, and so on. Second set of keys are W4, W5, W6, and W7, like that. So each round is getting four keys, right? So that's why this is I plus 1, I plus 2, and I plus 3. Now you take the first column, XOR with W1, second column, XOR with W2, third column, XOR with W3, fourth column, XOR with W4. Okay, and so on. And the result is placed into the output state. That's all. So this is add round key transformation, right? So these are the 4 transformations that we have seen, and this is the process again, encryption and decryption. I think now everything is clear what is happening in the AES. Okay, so that's it about AES. Thank you.